So, the floor to Ms. Hatζηγαβριήλ. Hello. We want to congratulate you for this forum, for the organization. It's an excellent opportunity for us to present our first pilot hybrid production of hydrogen from a small hydro plant for the production of electricity using fuel cells. First of all, I want to make a small, short introduction of the company. It was founded in 1992, and it's active in designing and development and maintenance of RES projects and energy storage. We first started with small hydro, and lately we are using the energy recovery from waste, and quite recently we're active in energy storage. This is some information about the company, but I don't want to bore you, so I want to talk more about the model energy park that we have in Agistro at Ceres, which is a space where we can develop and showcase energy technologies. In this context, in view of the projects and programs that our company has participated in the last years, European projects as well. This is some view of the park, of the energy park. On the left, we have the hydrogen unit. Then below, it's a Tesla battery, lithium-ion battery. Then we have the chargers for electromobility, and then the unit for biogas. Let's say a few more things about the hydrogen unit. It was implemented in the framework of the remote program for the Horizon 2020, in the context of the Horizon 2020. It's a fuel cell and energy and hydrogen storage in 3 demo cases. It's a feasibility study on that. You see the consortium, the participants. Besides, from us, from Greece, we have the Center for Research and Technology that participates. So Horizon ATE participates as with a demo case in this project in order to simulate a micro network in a remote area. Agistro is at the Greek and Bulgarian border. So in essence, it's a way to cover the requirements of an industrial unit that is close by using renewable sources. And we also have off-grid storage facilities there. You can see at the pictures with red and white the storage tanks for hydrogen and oxygen, and then the container that has the electrolyzer and the fuel cells. The power of the system is 50 kilowatts. The storage capacity is 1,000 kilowatt hours. The unit was installed at the start of 2020, when the discussion about hydrogen in Greece was at very primal stages, as we said before. This is the architecture of the system, power to power. The innovation of the particular system is that in a joint array, in a joint arrangement inside the container, we have the electrolyzer and the fuel cells. We have, when the hydro plant is in operation, it covers the requirements, energy requirements of the industrial unit. When it is out of operation, the storage unit takes its place. And I will give you a more detailed example afterwards. Here you can see the architecture of the system so that you can understand exactly where the batteries are, where the hydrogen tank is, where's the electrolyzer and the fuel cell. For the requirements of the research project, the pilot unit operates off-grid to create the conditions of a microsystem. These are the requirements, the energy requirements of the industrial unit, which we take in the simulation as load. Obviously, the needs are small. It's a small industrial unit, craft industrial unit. The blue lines are the curves for the annual generation of electricity. The dark blue is the production of 1 liquid year and a medium year, and the light blue is well, actually the light blue is a wet year, the blue in the middle is a mid situation, and dark blue is a dry year. Now let's see what happens in the case when the hydro plant is not operating, or if we have a power failure, because that's quite often in the area. It's a remote area, and this program emphasizes, this pilot project emphasizes how such a storage unit can help these areas. This complex graph, composite graph, shows us an incident of a power failure. The hydro plant is not operating. This is a 1 week graph, and then the battery of the system starts operating. It's the red line. It starts feeding the industrial unit, the load for the industry. This battery, must be clear, it's a backup battery. It's not just any type of lithium-ion battery. It's a backup battery to assist the fuel cell meet the fluctuations in the load. Therefore, it discharges within 1 day, and then the fuel cell is activated to cover the requirements of the industry. When the power plant, the hydro plant, starts operating again, it first it charges the battery, and then it feeds the electrolyzer in order to generate again the hydrogen that was consumed. Of course, this unit can also operate on-grid. We did it off-grid for the requirements of the project. Small hydro plants have a comparative advantage compared to other areas, because they can also operate in conditions without charging. Because they can have 2 charging cycles. However, because the legislative framework is not finalized, I have to highlight a specific issue with regard to small hydro plants that are combined with a storage unit. Small hydro is connected to the network via generators, synchronous or asynchronous generators. Storage units are connected through inverters, such as is the case with photovoltaic and wind parks. This parallel connection of 2 different technologies of generation may create problems. So, being here as a member of the board of directors of the Greek Association of Small Hydro Plants, aside from representing Horizon, I wanted to say that we need to address such technical issues in cooperation with the relevant operators, relevant agencies, so that the small hydro plants can play an active role in energy storage when this becomes a reality in Greece. Thank you.